All right, well, I will begin with a word of prayer. Seems like we lost some people in here, but anyway. Heavenly Father, we thank you for this day. Thank you for these students. Just ask you just bless our work today. Help us to glorify you in what we do, and help the students to ask good questions as they think of them, Lord. In your name I pray, Lord Jesus. Amen. So do you guys have any questions? We certainly have time for some questions today, if you got them. There is a quiz Wednesday, but the quiz will no longer be stressful. I don't think. I mean, like, it's going to be more of just if you come and you take the quiz, then you'll have credit for the quiz. So, no. I'm going to give you guys the proper sense of false security before the test so that you'll do worse on the test. No, that's not the reason. Just trying to make the class less stressful for you guys. So, yeah. The quiz, I will basically give the quiz and give you some time to work on it. All right? Probably not enough time, but enough time for you to try and get stuck. But rather than staring at you as you're stuck for 10 minutes, I will just then solve the problem and we'll talk about the solution together, and that will be the quiz. So you'll still get to see what a typical quiz would look like. That will help you understand what the test would look like, but you know, I won't be grading it. Basically, if you come and you take it, you'll have full credit. All right? So if that's agreeable with everybody. But let it be our secret pact to not tell all the people who are not here right now this change in policy. Let them think that it's going to be at the end of class under time pressure, and that I'm going to collect them and grade them ruthlessly. All right? Is my secret safe with you guys? Okay. All right. There's not one of you who's like a friend of one of the people who's not here and they're going to leak this information to them, is there? Nobody? Okay. Very good, very good. So, and in addition, when I give the quiz out on Wednesday, I'm going to collect it. I'm going to pretend I'm collecting it at a ridiculous time. Like, I'll give it out, it'll have like 15 minutes worth of problems, and I'll like try to collect it after like 2 minutes. All right? So you guys, and when I do this, you should all pretend like you're done and act like the rest of them are idiots. That's like the full. That's the proper joke. Let's see here. My father was a math major, and he didn't really like math, as far as I can tell. He died a couple of years ago, but he had a stroke like when my kids was born, and so he hadn't been himself for a while. But he I never had a conversation with my dad about like how much he loved this particular math class or something, right? So like as a math major, and then your son's a math major, you don't ever talk to him about, oh, I really like this thing in that class or something. Like that conversation never happened. For him, the math major was just a means to get into medical school, right? So he had this one class he told me about that he was having trouble with it, and he and his friend were both having trouble with it, and they're like worried about passing the class. They go to the professor like, sir, we don't think we're going to pass this class. We don't know what to do. And he's like, well, if you just do all the homework, and sometime I'm going to give you a question, and when I give you a question, you got to ask the question in class when I give you the signal. If you can do that, I'll pass you, no matter what else happens. So like, okay. So he fed my dad and this other guy like really good questions to ask at certain points in lectures, which probably made my dad and the other kid look like really intelligent and stuff. But I don't know. I like that idea. I have not done that yet, but anyway. Oh, example. Unless you guys have a question. Yes, every quiz from now on is going to be like this. But the tests will still be time pressure, annoying, blah, blah, blah. Okay, so, however, if you're not here, you missed the quiz. So, yeah. All right, so example 1. Let's solve a inequality. How about this? 3x plus 1 over x less than 2. How would we solve this inequality? What should we do here? Clear the fraction. See, I mean, that seems like a really good idea, but the trouble with that is that when we clear the fraction, we're multiplying the inequality by x, and then we're obligated to break into 2 cases, one for x positive, one for x negative. I try not to do that kind of thing. I want to keep all my eggs in one basket, so to speak. So what I want to do is I want to convert this to an inequality that compares some expression to 0. So like my opening move is just to subtract 2 to the other side. Like that. See, now I can do the number line trick, but I can't do it yet because I then need to put this into like common denominator, right? So how do you make 2 into a fraction with x? You just do what? Multiply by x over x, right? Like x over x like that, yeah? And see, now I've got the common denominator of x. That gives me 3x plus 1 minus 2x, all divided by x, less than 0. And we can collect terms. What do we got here? We got a x plus 1 over x less than 0. Hooray! Now we got it. What are my critical numbers? So either the numerator is 0 or the denominator is 0. The denominator is 0 when? X equal 2? It's kind of silly. 0, right? Yeah. How about the numerator? When can the numerator be 0? X equal to what? Negative 1. I put that over here, right? Now I just need to test some points. And test one point and use the sign flip. How about that? If we plug in like 1 into this, what do you get? 1 plus 1, 2. 2 divided by 1, 2. Positive, right? So we're positive if we're over at 1. So we got pluses over here, right? Both of the factors have multiplicity 1, so we flip the sign each time. Now we can answer the question, right? Where is it negative? Just right here, right? So what's my solution? Solution set equals to, like you just said, minus 1 to 0. We have a winner. There we go. So that's not too bad, is it? But this is very hard if you don't have the idea to make it relative to 0 and then to make it into a fraction. Like, those steps are critical. You have to make those steps in order to get to the point of being able to use the number line to solve it. Yeah, minus 1 to 0, just where it's negative, because we're solving less than 0, right? If we were solving the greater than 0 problem, the answer would be, you know, like minus infinity to minus 1 unioned with 0 to infinity. Now, if we were, let me modify it a little bit, okay? If I was making this problem less than or equal to 2, that would put the equals here, and here, and here. Then I'd look for where it's equals to 0. Now, 0, no good. That's division by 0. But the minus 1 would then be included. So instead of writing the parentheses here, I'd write the square bracket like that to include minus 1 in the solution if we change the problem like that. Okay? Okay, so let's look at another example. I'll make this one a little bit kind of a different kind of simplification problem. Suppose you've got x plus 4 times x squared minus 25 quantity squared, all right, times x squared plus 2x plus 1 divided by x squared minus 3x plus 2 times, oh, I don't know, x squared minus 16. And we're going to solve that. That's going to be less than or equal to 0. Let's try to solve this problem. So here, it's a little bit easier in some sense than example 1, because I don't have that problem of bringing everything to one side and comparing to 0, right? It's already nicely less than 0, right? Like, so we've got that part is kind of nice, but then what? I need to do what? Multiply out? Ooh. Opposite of that. Opposite of multiply. Factor, right? Factor. So let me do that. So what we have here is we've got x plus 4. And what is x squared minus 25 factor? X plus 5 times x minus 5, right? And that's squared, so I have to square this one and square that one. And then how about this? This is x plus 1 squared. Do you want me to explain? I can.
I just can't see that.
Oh, I'm sorry. You're past the event horizon over there. I think if you go back a chair, it'll be better. It's just optics. It's kind of counterintuitive. Go away from the board so you can see it. Yeah, okay. Whew. I guess that optics is good for something. I hate teaching optics. Anyway, so this is x minus 1 times x minus 2. This guy, x plus 4 times x minus 4. Now let me simplify this out. So some things cancel, right? Do you see that? Oh man, I was trying to make this thing cancel with that thing. I failed. See that? I failed. Oh well. I'm gonna leave it like it is. I was trying to get this thing to cancel with one of these, but oh well. It's just distinct. So we'll just have this cancellation, right? That's pretty much it. I think everything else stays put. And this is going to have a really weird solution set. X plus 5 squared, x minus 5 squared. Everything's squared. My goodness, this problem is like the most squarey square of the squares. And then x minus 1, x minus 2, x minus 4 less than or equal to 0. All right. I think we have combined all like terms possible. We have everything completely factored. This is simplified as much as possible, right? And we want to maintain the factoring because that's how we understand things here. Okay, so what are my critical numbers? I've got minus 5. I think that's the most negative one on the most left number on the number line. Minus 5. What comes next? There was a minus 4, right? But it bloop, it went away. Oh, minus 1. Okay. And then what else? Oh, 1 and 2, 4. And 5. All right. Now what I usually do with something complicated like this is just chuck a big number into it because it's easy to think about. Like plug in 10. If I plug in 10, I've got a positive number, 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 a positive number. So it's all positive. So that informs this plus that I'm going to write over here, right? And then this one's really wacky. So like x minus 5, the multiplicity here is 2. See that? Which makes me stay positive. Now x minus 4, well that's got a multiplicity of 1. There's just one of those, so I flip signs. All right? You might not have understood the sign flip thing the first time I did it. You might not have understood it the second time I did it. But this is like the 15th time I've done it. I hope you're starting to see what I'm doing. You got it? Okay. Well, one of these times it's going to stick. All right, so 2, that's from this one. It's odd, so we flip from minus to plus. Yep. Oh, you said negative. What? It flips because 2 is odd. This is x minus 2 right here. So there's just one of these. So as I go across the critical number 2, I change from minus to plus. Whenever the factor is odd, you have to flip signs. Not the number inside the factor, but the power of the factor, the multiplicity of the factor. Like these squared ones, they don't change. Yeah, all the multiplicity here is 1, so it flips. Now this one, what do we got? Flip or not flip? See, that's coming from this right here, right? No. So we don't flip, we stay negative. And how about minus 5? Well, that's coming from this guy. So it stays negative. All right, so there we go. All right. It's wearing me out today. What's the solution set then? Let me circle it. We're looking for where it's negative this time, right? So like this one, this one, this one, and that one, right? Yep.
How do we know that we're looking for it negative?
Oh, because we're solving the less than or equal to 0 problem. That's what makes us look for negative. We're looking for where the expression's negative. If it was greater than 0, then we would be looking for the pluses. Good question. So the solution here looks to me like it's minus infinity to minus 5. Now, do I include minus 5? I think I do because it's making the numerator 0. And then unioned with minus 5 included to minus 1. Now, how about the minus 1? Where's that happening? That's in the numerator as well, so I have to include that. And then I'm going to union with minus 1 to 1. Is the 1 included? Oh, well, 1 is a troublemaker. See, because 1 gives you division by 0. So we exclude 1. So 1 parentheses. And then we take the union with 2. Now, is 2 included? No, 2 is a troublemaker. 2 is in the denominator. So that would make the denominator. Plugging in 2 into x minus 2 would give me division by 0. I exclude 2. That's parenthesis. And then 4. Well, 4 is, again, one of the denominators, 0, so I exclude it. So that would be the solution set. Let me check on that. Now, we can simplify this, right? Right. Logically, this is the same as minus infinity to 1 excluded, unioned with 2 to 4 in this case. Yeah. You could do that. Yep. Now, if I didn't have less than or equal to 0, right? If I just had less than 0, then we wouldn't have been able to make that last step, right? If I just had less than 0, then we'd have just had the union of these, and we'd be like missing minus 5. We'd be missing minus 1 from the solution set if we had strictly less than 0. It's because we had less than or equal to 0 that we're able to join those, glue them together by their endpoints. Any questions? Let's look at another one. So at this point, I'm going to go back in time a bit and work a problem that we haven't worked yet. I mean, maybe we've worked this problem before, but let me work it again, or something like it anyway. X minus 2 plus x equals to 3. Let's see if we can solve this thing. All right, let's solve this equation. So I'm taking a step back. I'm going to solve a rational equation. I think we've done enough rational inequalities for now. Let's look at equations for a bit. Again, I'm circling back. Oh, thank you. Was I over there before? Okay, cool. So what do you guys think? I think what I want to do here, in the last class, the way I solved something like this was just to multiply by the denominator. But I think a better move here would be to isolate the fraction first. Like this, right? If I do that, then I can like cross multiply, and it kind of works out prettier, I think. See, because multiply by x minus 2, what do you get? like that, right? And then we just have to multiply that out, right? Multiply that out, what do we get? We got a 3x minus 6 minus x squared plus 2x. All of that's equal to x. I don't like having minus x squared. So what I'm going to do, I'm going to move the minus x squared to the left-hand side. I'm going to put all of the variable term. I'm going to put everything equal to 0, okay? So I've got x squared. That's what? How many x's do I have? I move over here. I got a 5. Move it to the other side. Minus 4x, I think. The only constant here is that minus 6, so that becomes plus 6 equal to 0. Are we good? Yes, no, maybe so. Now, I just made up this problem. If we can factor this nicely, that would be an amazing coincidence. Like, amazing. But what I will do is complete the square. So this is x minus 2 squared minus 4 plus 6. Ooh, look at that. Look at that. X minus 2 squared equals to minus a 2. What's that mean? It's a prime polynomial if I go back up a step, but that makes it clear that there are no real solutions, right? Because I can't have a real number. Well, if you want, I can solve it. X minus 2 is equal to plus or minus the square root of minus 2, which means x is equal to 2. That is really annoying. Plus or minus, shut up! I root 2. For the people who aren't here, I was not talking to the board. I was talking to a particularly belligerent student. That's just how I roll. So, all right. Oh, yeah, but if we were looking for complex solutions, then fine, but we're not, so, yeah.
Why isn't there a solution?
Because the solutions are complex. If they're complex, they're not real.
Yeah, but why isn't there a real?
Why? If you're asking why there aren't solutions, I can explain it to you. Here's what it is. This problem is equivalent to x over x minus 2 is equal to 3 minus x. All right? This right here, we can graph. Actually, it's got a y-intercept. It's got a vertical asymptote of x equals to 2. It's got a horizontal asymptote of 1. Shut up! Goodness gracious. I'm going to have to bring some WD-40 and just spray it behind the wall. So like, if I put this equal to y, I can... I'm starting to think you guys are on the board side. Let's see here, monsters. It goes through 0 at 0, right? This is 0 when x is equal to 0. And its graph looks something kind of sort of like this. Now you're like, are we responsible for that? Well, yes, but not yet. We will spend a whole lecture, maybe 2, just on how to graph these things, okay? So I'm showing you something from the future. From this, I can see the vertical asymptote is 2, and staring at it, I can see the horizontal asymptote is 1, and so it does something like this. This is the graph, all right, of that. Now, that's the graph of y equals x over x minus 2, right? Okay, great. You guys are too easily amused. Now this, on the other hand, y equals 3 minus x, that is a line. This you already are responsible for graphing, right? Its slope is minus 1. Its y-intercept is 3. So that looks something like this. And as you can see, never the twain shall meet. There is no point of intersection. That is why the equation only has complex solution, because these graphs have no intersection point. Now, I can't always find a graphical interpretation for why there's no solution, but usually I can in this class. If you want to understand why there are no solutions, you can look at the equation that you're looking at, look at it as a pair of graphs, and see that those graphs have no intersection point. usually that's a way to understand why there's no solution. On the flip side, if you want to understand what the solutions mean, a lot of times you could think about a pair of graphs, and what you're doing is you're finding places where the graphs intersect. But anyway, I think I did this in here last time, didn't I? With Desmos? Yeah. I've done this 0 times for the other section. You guys have a better deal. Anyway, you guys were like 20 points higher than them on the test. Like the average is 20 points higher. So, yeah. Although that's not unusual. Like sometimes it's not unusual for my sections to have like a 10-point difference, but 20 points, whew, that's a lot. All right. It's probably, I think my teaching is worse than the other section, honestly, guys. Like, seriously. Example 4. All right. So this is like problem 42 in the mission. I need to work a problem like this because I usually give this on the test, and it usually stumps a bunch of students. So let's just confront the problem. So I need to talk about laws of exponents, all right? And so laws of exponents, in particular, if you have ab to the power s, that's a to the s, b to the s. That's one thing. If you have a to the s raised to the t power, you get a to the st. That's another law of exponents. I think we talked about this one before. If you've got like a to the s over a to the t, you get like a to the s minus t, right? Or you could do it as 1 over a to the t minus s, if that floats your boat. If you want to do it that way, you could do it that way. These are options. Now, another thing I should talk about is the radical notation. So if I've got like square root of a, we can understand that as a to the 1/2. All right? If I have the nth root of a, well, that's a to the 1 over n. All right? So, for instance, if I was up against like the cube root of a squared, how would that simplify? Well, that would be a squared to the 1/3 power, right? Which I could write as a to the 2/3 power. So if you have like a radical of a square or a square of a radical, then you can like multiply the fractional power of the radical and the power inside what goes in there. Okay, so these are some of the rules of the game, all right? Now let me set up the problem here. So suppose you got something hideous like this: square root of x cubed y to the power 5, x cube root of y all to the minus 1 power divided by x to the power 6, then the 4th root of x to the 4th y to the 8th. There we go. And this is equal to x to the a, y to the b. Find a and b. So this is basically this is problem 42 is something like this. It's probably simpler than this. I don't know, maybe it's uglier. I can't remember. I think if you can do this one, you ought to be able to do problem 42 in the mission, all right? You guys could be asking me about mission questions anytime now. You don't have to wait until the day before it's due, and then we don't have enough time to answer your questions, you know? Like, we've got time now. Where's the fun in that? Yeah, fine. All right. So what I want to do is I want to simplify this. All right. So let me just take it piece by piece. So I'm going to start out with, that's the square root of x cubed, square root of y to the 5th, x to the minus 1, the cube root of y to the minus 1, divided by x to the 6th, the 4th root of x to the 4th, the 4th root of y to the 8th. All right, and I'm going to give this thing a name. Pac-Man. There we go. So Pac-Man is equal to this. Great. So we can simplify some things here. And what I'm going to do is I'm just going to convert everything to fractional powers, because then we can make quick work of it. We have to start with x to the 3/2 power. Then we have y to the 5/2 power. X to the -1. Y to the -1/3 power. All right? What is the 4th root of x to the 4th? Now, I need to say something. We assume x and y are greater than 0, okay? If I wasn't assuming that, then I got to worry about, like, remember we had the square root of x squared was the absolute value of x? I'd have to worry about that issue. But I don't want to worry about that. So we're going to assume x and y are positive. So in that context, the 4th root of x to the 4th is just what? Just x, yeah. Because x to the 4th to the 1/4 power is x to the 4/4, which is equal to x to the 1, which is, of course, just x. So that's x. And I'll write it as x to the 1. And then you got plus y times y to the what? What's 8/4? Second, yeah, y squared. All right. Now we have everything nice and tidy. And we can just add up the powers of x and add up the powers of y. So let me just go ahead and do it. I have x to the 3/2 -1 -1. Well, -6 -1. And then y to the 5/2 -1/3 -2. Let me do some color coding there to try to explain to you what just happened. This 6 gave me this -6. This 1 gave me that -1. All right? And the division by y squared contributed that -2 at the end of my y exponent. So I just add the exponent. When I multiply x's, I add the exponents. So like 3/2 -1. And with the y, 5/2 -1/3. And then we need to clean things up. So you guys got a calculator? Can you help me out? Yeah, me too. Not in your dorm, but obviously. I don't really know which dorm you live in. I'm assuming it's one of the ones that towers over us around here. Or do you live in one of the less grandiose dorms? Are you in a mega dorm or like a?
I'm in Commons.
Commons? Is that like a little dorm or? I don't know.
I don't have a point of reference.
You don't have a point of reference. All right. Well, like the one where the Dunkin' Donuts is, I refer to that as a mega dorm because it's like it's ginormous, you know.
I do not have a Dunkin' Donuts.
Okay. No Dunkin' Donuts.
Unfortunately.
So you guys tell me, what's 3/2 minus 8? Minus 13/2. Okay, that sounds about right. And then y, what is 5/2 minus 1/3 minus 2?
That's 1/6, isn't it?
Anyone care to confirm or deny those numbers? I see a calculator. Does it
It doesn't work. I don't know how to work it.
Ah, rats. All right, you've driven me to this.
So I am just figured out how to make minor fractions last test.
Let's see here. 5/2 minus 1/3 minus 2.
5 divided by 2.
0.166666666. Otherwise, that's a sixth. We're good.
0.
Shut up, Google lady.
From
3/2 minus 8. I think you're right about the other one. Minus 6.5. Yep, that's good. Just double checking. All right. So if that's what we get, we simplified it down, right? Now we look at this as x to the a, y to the b, and we compare. What does this tell us a equals to? And b equals to? Minus 13/2 is a, and b is 1/6. There you go. A related question. What if you wanted to simplify this expression and write it in terms of x and y to positive powers? This wouldn't be the answer then, right? If you wanted to simplify it using x and y to positive powers, then the answer would have been y to the 1/6, right? Divided by x to the what? 13/2. See, we could have written Pac-Man like that. If we wanted to express Pac-Man as a rational function, well, it's not a rational function, but as a function just involving positive exponents, that would have been what it looks like. The reason this is not a rational function is once you have radical expressions like fractional powers, you've left the world of rational functions. You're now in the world of algebraic functions. And algebraic functions are, well, they're different. So, you guys want to know what the definition of an algebraic function is?
Yeah, sure.
It's really, what's that?
More evil.
It's more evil? No. So like, a function is algebraic if its formula is built with an algebraic formula.
Well, what the heck is
If algebraic formula is one that's built from a finite number of products, sums, differences, quotients, and radicals. So,
basically it?
oh, there's more than that. We learn exponentials and logs at the end of the course. Those are transcendental functions, though. A transcendental function is a function whose formula transcends algebra. That's kind of a glib way of saying it, but at the end of the course we talk about them like logarithms and exponentials. So, can I erase? We good? Okay. So anyway, I wanted to show you guys a problem like that so that you've got a, you know what to do for problem 42. All right? And it's a pretty good check on whether or not you really understand the laws of exponents, right? If you understand the laws of exponents, you should be able to simplify carefully and get the right answer, right? If you can't do that reliably, if as you do this multiple times you get different answers, there's something wrong with your tool set for algebra. You need to figure out what you're doing wrong and like get it out of your system so it can't, I got enough points. I don't need more points. Keep your points. You know what I'm saying? Like I don't want any more points. You guys, I want 100 for everyone on the next test. No. Wait a minute. That's not good. How many points do we have on a test? I want 150 for everyone on the next test. 100 would mean everybody gets a D. That'd be bad, right? We don't want that. So, where are we? Example 5. I'll tell you where we are. It's time for us to talk about radical equations. And guess what a radical equation is? Something with exponents. I like the general sentence structure you're setting up there, but a radical equation would be an equation with radicals, yes. Radical equation is an equation with radicals. How do you solve an equation with radicals? Well, let's talk about what a radical is. So first of all, to say that you have the nth root of a is equal to b, right? What does this mean? This means that b to the power n is equal to a, and also that b is greater than or equal to 0 when n is even, right? If n is odd, whatever. So if n is odd, there's no strings attached. But if n is even, we insist on taking the positive root. Let me show you what I'm talking about. So like example Where was I? 5. Example 5. If you think about like the fourth root of 16, all right? That would mean you're looking to solve, if that's equal to x, right? That means you want x to the fourth equal to 16. Well, what are the solutions to this? Well, we know how to do that. That's x to the fourth minus 16 equals to 0, which is x squared minus x squared plus 4 times x plus 2 times x minus 2. That's how that factors. So what are my solutions? My solutions are x is equal to plus or minus 2, right? There are, in fact, 2 solutions to the x to the even power equal to 16 problem, right? Only one of those solutions, though, is the fourth root of 16. So by definition, the fourth root of 16 is the positive one of these solutions. It is equal to 2. All right? You can try it out in your calculator if you have a calculator. If you do 16 to the 1 over 4 power, you should get 2. All right? This is something you need to figure out for the next test, is how do you calculate number to a power on your calculator. Something you need to be able to do. So no time like now to start working on that. Now example 6, on the other hand, let's see how this goes. What if we're talking about like the cube root of minus 8? So suppose that's equal to x. What does that mean? What does that mean? By definition, that means you're looking for something that has x cubed equals to minus 8, right? Well, we know how to solve that. That's x cubed plus 8 equals to 0. And if we factor that, how does that factor? Remember? This is the x plus 2 times x squared minus 4x plus 4 equals to 0 problem. And I think that was supposed to be a 2 in the middle. My bad. I hope I didn't do that wrong in the other section. They wouldn't tell me. Well, anyway, the deal is, though, that quadratic is irreducible, as we discussed before. It has no real solutions. It's not no real zeros. Like the zeros for it are complex, right? So the only real solution to this problem is what? X equals to minus 2 is the only real solution. So we can say, you know, x equal to the cube root of minus 8, which is in fact here equal to minus 2. And there's no need for like quibbling over which is it, the plus or the minus, right? So if we take the fourth root of an equation, let me just kind of like, what's the long and short of this? It's pretty simple. But it's also, it's a source of some confusion if we're not careful. And it doesn't really come up too much, honestly. In fact, I try pretty hard for it not to come up in here. But it is nevertheless an issue we should be aware of. And if you go on, it does matter. So here's the deal. If I have x to an even power, all right, let's say like 2n, all right, equals to something, let's say a, then x is equal to plus or minus the 2nth root of a, all right? But if we have x to the 2n plus 1 power, so that's an odd number, right, equals to a, then x is equal to, guess what, the 2n plus 1th root of a. There's just one solution, end of it. So there's two solutions for an even root. If you're solving x to an even power equal to something, there's two solutions. If you have x to an odd power equal to something, there's just one unique solution. We've already seen this. This is the square root property, right? This is the square root property. It's also true for fourth roots or eighth roots, any even root, right? Okay, so there's that. I mentioned to it, I feel like I should mention it to you because it is an issue, but I try not to belabor that. So let us work one interesting example while the day is not done. Two, actually. We'll work two interesting examples. Example 7. Suppose you're solving the square root of x plus 1 equals to 3. Example 8. Suppose we're solving x to the 2/3 power equal to 64. So how do you solve the first problem? What is the natural enemy to the square root? The square, right? So square this thing. And we get x plus 1 equals to 9. Therefore, x is equal to 8. Yay. It can be that simple, right? That's easier than the rational problems, isn't it? Yeah, for sure. How about this one? How do you get rid of the 2/3 power? What do you do to the equation? Squaring it won't help. Squaring it, they'll just make the 2/3 convert to 4/3. That would be bad. The cube root of x squared. Cube root would make that into a 9th power. 3 times it. How about this? What if I do it to the 3? And somebody already said this, my apologies. But take both sides and raise it to the reciprocal of 2/3, namely the 3/2 power. That's something you can do. Take both sides of the equations to the 3/2 power. Then we use our law of exponents. What's 2/3 times 3/2? Well, it's 1, right? So that gives me x is equal to 64 to the 3/2. Now, what is 64 to the 3/2? Well, that is actually the same as 64 to the 1/2 cubed, and that I can calculate. Well, that's the square root of 64 cubed, which is 8 cubed, which is, I don't know, 2 to the 9th, so 256, I guess. I could be wrong about that. Maybe it's 512. 512. I think that's right. 64 times 8. 640 minus 144. No, 60. Okay, cool. Yeah, I remember this from like computer science classes. 2 to the 10th is 1024. That's actually a kilobyte, right? A kilobyte's actually not 1,000. It's 2 to the 10th. So it's a binary thing. Anyway, hey, that's it for today. I'll see you guys next time. Remember, stress about the quiz. Very stressful.